Finally, let's have a look at the ST graph of this question, which is probably the most complicated question. Again, I suggest to first look at the numbers before we draw anything, so we know what's the scale actually of our drawing. Now we know that we can find the ST graph by looking at the area under the curve on the VT graph. For example, we could look what position did we end up if we calculate the area under the curve. So here from 0 to 7 seconds, I suggest we do several points in time. So here we could, for example, start doing first area A1. A1 is half of that velocity plus that velocity, 1/2 of, we started with 14 meters per second. Here I am at, actually in my VT graph I completely forgot to put the scale in, 10 meters per second, so let's do that right now, 20 meters per second plus 20 meters per second times the change in time, delta t, which was 2 seconds, So if I look at that, my 2 goes away, my seconds go away, and I end up with something positive in meters, which is 34 meters. If I look what happened until, let's say, from 2 seconds to in the next 2 seconds, over here, this is my, actually what we had here was changing position from 0 to 2 seconds. I change in position from 2 to 4 seconds, that will be my A2. Let's calculate this. It's 1/2 of 20 meters per second plus 26 meters per second times 2 seconds again, and the 2 seconds go, is a change of another 46 meters. Now let's jump straight to 7 seconds. I could either calculate the changes that I have to add from 4 seconds, 2, 3, 4 to 7 seconds, or I could calculate the change in position that I got directly from 0 to 7 seconds. Let's do that. Let's calculate that big area here. Should be my change in position from 0 seconds, pay attention, 0 here as I start down here, to 7 seconds, which is, again, the average velocity actually between, because I have a straight line here, so I can go 1/2 times 14 meters per second, plus at the end I had 34 meters per second, times 7 seconds in this case, which gives me 14 plus 34 times 7, 168 meters. Now while we were slowing down from 7 to 9 seconds, we still went forward. So we have a change in position from 0 to 9 seconds of 1/2 of 34 meters per second times 2 seconds, and 2 goes away, my seconds go away, it's exactly 34 meters. Then my change in position for the last segment of the journey from 9 to 11.1 is 1/2, because it's a triangle, right, of 27 meters per second times 2.1 seconds, which is 28.3 meters. Let's just do that, 28 meters. So now I know I'm actually going to end up, these here is that 3 are going to add up. So this plus 34 plus 168. That means at the end I'm going to be at 230 meters. So I have to have a scale which allows me to draw 230 meters. So let's just assume here, do our ST graph down here. This is going to be 250, 200, 150, 100, 0 meters, 100 meters, 200 meters. Here, time scale again. Seconds. 1 second, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 seconds. So I know some points on that graph. I actually don't know where we started, because I've started anywhere. Let's for simplicity choose 0 as a starting point. And I know from 0 to 2 seconds we went up by 34 meters. So at 2 seconds and 34 meters, right? Let's put a point here. And from 2 to 4 we went up another 46 meters. That means 34 plus 46. I ended up at 80 meters. 50, 75, 80, around here. Then at 7 seconds I was at 168. 50, 75, 68, somewhere here. At 9 seconds I went up another 34, so therefore 168 plus 34. I was at 202 at 9 seconds. Also at 9 seconds I know that my velocity was 0, therefore my slope here must be horizontal, because the slope of the ST graph is the velocity. Then at 11.1 seconds we went up another 28, which brings me to 230, somewhere here. Now I guess between those points we can draw it pretty good. We don't really know is in 0, we actually know we have some positive slope. What's our slope? Our slope is 14 meters per second at 0, so we could actually look at this is 25, so this is probably 14 per second, so therefore my slope here started at something like this. You can look at our slope at 2 seconds. At 2 seconds we have 20 meters per second, something like this. At 4 seconds we have 25 meters per second, and then the slope goes gradually down towards 0 here. So let's try to connect those lines with the parabola. Here at the end, again, we were at 27 meters per second, so in 1 second we went up by 27 meters, therefore our slope here at the end should be something like this. It needs to join our horizontal line. And there we have our ST graph.